Thanks for having me this evening. Yeah, my name is Milecia McGregor, and I'm a developer advocate for Conducto. And we just make these really cool CI/CD tools where you don't need to use YAML and you can just go through your pipeline nodes like a file structure, basically. And also, if you're interested in more React stuff and more just tech stuff in general, you can follow me online on Twitter at Flipped Coding. So tonight I want to talk to you all about managing state in React SPAs. Well, okay. Before I jump into any talk, I always like to give a quick overview so you know when you can kind of tune in and tune out on the parts that are the most interesting to you. So the first thing we'll talk about is why states need management in the first place. So what makes it such a hard problem where we have so many states that need just like this crazy separate system? And then we'll talk about what causes issues when it comes to state management. So what makes those performance lags or those really weird rewinders that take forever to figure out. And then we'll talk about the big surprise, which I hope isn't too big of a surprise, but if it is, that's even better. And then we'll talk about some of the built-in state management tools, which makes things so much cleaner than what we'll reveal in the big surprise. And then we'll talk about like sometimes you should probably consider using a state management tool. And finally, we'll just wrap up with some key takeaways and a few things I hope that you can take to work tomorrow or use on any of your side projects. So the first thing, why do states need to be managed in the first place? It's just a web app, right? There's nothing that should be so hard to keep track of. But when we work with these single page applications, there's a lot of components that interact with each other. So you might have a form that triggers the drop down list to load based on the other inputs that are set. Those are really common components now. And it just makes sense it just makes sense to have different states that hold like when I don't know how to turn that off sometimes. But anyways, so it just makes sense to have something that can tell you, hey, this form was set to this value, so we're going to pass it to this component. And basically what this does is the core of what enables us to have single page applications in the first place. Our states let us change components based on different interactions that happen on the page. And then, of course, forms are everywhere. It doesn't matter if they're asking for your email address or your social security number, whatever they're trying to get, there's a form on basically every website. And so this leads to different things like what page should you get routed to afterwards, or what values should get saved for your specific user, or how should the page load next time you log in. Those forms drive all of these other decisions because they're what makes the page dynamic. Basically, we use our forms to do more than just save user data. Users have a level of customization now that just didn't exist before because pages were a lot more static, or we were working with jQuery, which made it a lot harder to do, almost everything. But the point is that forms drive how these SPAs work. Based on what your user's input is, the whole form might change. That's where state management becomes important. You need to keep track of all of these different form inputs and how those values work with the other parts of the screen. Because not only are you worried about authenticating users and making sure that they have the right permissions, to see these new components based on the current state of a form, you need to be able to quickly and very user-friendly you make these updates. And with state, you don't have that choppiness of jumping around to different pages and having to download resources at weird points in the page rendering. That's why we need state management. And then users just have certain expectations. When they start to type, say, anything into a search box, if you have a list on the screen, they probably expect some kind of filtering or sorting to happen. And basically what that means is we have to be able to design these SPAs to meet their expectations, or else they won't use our application. It's really that simple. Users have a certain expectation for how apps should perform, and we use state as a tool to make sure that they get the experience that is the best for them. And what that means is when they're interacting with the page, whether it's toggling a button or clicking on some kind of image, that triggers some kind of on-page interaction. And with those interactions come this really intricate web of values that depend on each other. And if any of those values ever get crossed, it causes all kinds of render problems. The page might not load. The catastrophic things happen when state management gets really messed up. And so when you have a messy state, users aren't going to get the experience that they're expecting. They're going to see all of those bugs because you haven't managed the state correctly. So if nothing else has convinced you to make sure you focus on state management, think of your support team. They're the ones that are going to have to take all of these angry messages from customers and users, and it's going to make their job a lot harder, which is going to make your job a lot harder. So if you take some time in the beginning or during a refactor of a project to check out your current state management, it'll make things go a lot smoother as you keep working on this specific SPA. So now we'll talk about some of the issues that poor state management causes. What we were talking about before is why state management matters. And the main reason was it makes the page work like a user expects. So now we're going to figure out what makes the page not work like a user expects. This is more of the behind the scenes that they don't get to see, thankfully. But a lot of times as these applications grow and they get more popularity, we add features. And we all know new features means new components that interact with all of the existing data components and whatever libraries we have installed. But as these components increase in number, that leads to this issue of prop drilling, where maybe you have a certain value that needs to carry through to, I don't know, a component that's nested 4 or 5 levels deep. It's really hard to follow that after a while, especially when you have components that are being used all across the application. When you're not just working on an isolated component, which is really rare these days, prop drilling can become a problem a lot faster than we really see coming, because when you're working on active development, the goal is to just get the feature out the door, get it into the customer's hands, get it to QA, whatever the process is. You're just constantly being pushed to get it done. And what this leads to is all of these nested components that depend on some top level value that gets passed down in just some weirdly convoluted ways sometimes. And that's just a natural side effect. It's not something that's like a beginner mistake or anything. It just happens over the course of a project's life where you add components, you might not have time to go back and refactor like you thought. And as the project goes on, you find that you're a little bit stuck with them. And that's also tied to this problem of component nesting. So like I mentioned earlier, you could have a form that just starts with one user input. Maybe they put in their address, and then you have to populate this list of fields based on that address. So maybe you need their zip code or their country or whatever else it is. It just makes the form load dynamically based on the input users have given so far. And the reason we do that is we like to keep these components separate so that we can see like the individual styles, the different functions that are specific to a component. We like to keep things modular. That way, hopefully we can reuse them over time. But when we do that, it leads to this level of nesting where it also gets a little bit hard to track where values are coming from, where they're supposed to go, who made this component in the first place. It brings up a lot of unknowns that just don't have to be there if you're properly handling state management. So if you find yourself nesting a lot of components, stop for a minute and think about the way you'll handle props being passed along. If you don't need to pass anything, then sure, go crazy, whatever, it's all function components. But if you have anything that's dynamically loading and it depends on data being passed to it from some parent component that's 3 or 4 levels above it, you should really take some time to, I guess, just think about the overall architecture of the feature you're making, because maybe there's something in there that can be simplified, or there's something in there that can just somehow be modularized to be reused in other places. And then again, components just become more dependent on user input. Sometimes there's no way around it. We can't hard code all the values, or else there would be no point of calling it an SPA. It would just be a static page. But as components become more dependent on our users, we have to also make sure that we validate the inputs, because sometimes we'll have the right value in one component, but because of some weird form validation issues, or maybe something gets formatted differently in a nested component, that value changes mid prop drill, and those take a while to figure out just because of how a project might be structured. But basically, as your components become dependent on this input, you need to be able to watch when that input changes. A lot of times when we're working with user input, maybe we need to load some new data based on what they type in or the different values that they select. So maybe they have a form where you just want to filter a list. You just want to show the results that you're searching for. That makes an entire list component dependent on a user input, which means that the API call is dependent on a user input. You don't want those values to get crossed up, because not only will that slow your app down, make it do really weird things, it leaves you open to different security vulnerabilities. When you're not able to, I guess, what's the right word? When you're not able to consistently track the way that your data is moving through components, it makes it hard for a new person that comes in to figure out how a system works. It makes it hard for external users to figure out how a system is supposed to work. And in 3 months, it's going to make it really hard for you to figure out how it's supposed to work. So as you notice the number of inputs increasing, make sure you're doing the basics like form validation. If there's any sanitation you can do to the data, make sure you do that. Just be very careful as you're adding these inputs. And now, this is my favorite part because it's the big surprise. You don't need Redux. Like, you just don't need it. It's a great package. It's wonderful for what it does, but for most applications, it is way overkill. You don't normally need this level of state management. Like, if you're working with Redux, you must have some kind of app. Like, it's just React has come so far in the tools it has built in that it pretty much made the need for Redux obsolete. If it's left in a legacy tool, you might even consider refactoring it out just because of the different methods and things that React has added on over the years. But this is the biggest surprise. You don't need Redux, even though it might be nice to use, it might feel more familiar, but you don't actually need it to manage your React app state. And the other part of this surprise is that you really don't need any of the other state management tools. No, one of them is what, MobX, which is basically Redux, but with multiple stores instead of just that one giant one, which, pros and cons. But either way, you don't need a state management tool when you're using React. If you can take the time to like architect a React app, it's a lot better to just use the React hooks and don't worry about Redux. But if you're working on an older system where the class components are still being implemented, Redux might feel a lot better just because it gives you those particular methods to work with, and it just works for that version of React a lot better than it does the newer ones. Speaking of which, we're finally at the point we can talk about the built-in tools. So, y'all are probably familiar with these just from work. But we have useState. So a lot of the built-in React state management tools come in the form of the hooks. If you're not familiar with the hooks, I would really advise you to give them a thorough read-through. The first two that we'll cover are relatively straightforward, but the last one, definitely you should go read about it. I thought about doing an example of it, but yeah, when I tried to do this I'll be honest, I tried to go through my demo app a few minutes before, and of course the big example is broken because that's how it works when you're about to do a live demo. But we'll go through the first two just so you'll see kind of how this should work in a real app. But the first hook is useState. And pretty much what useState does is exactly what you think it does. It sets the state for different components that are on the screen. So in this example, we have just this goal list, which is an array of objects. So we just defaulted to this empty array. Another thing I would highly advise is to use TypeScript along with React. This is like one of my side projects that I use for demos sometimes, and really need to get around to updating this to use TypeScript. But anyways, when we use the useState hook, this pretty much just says, hey, I'm gonna watch this particular value that's used in this particular place, and I'll keep record of it as long as we are on this page. Which is perfect for an SPA because we're always on this page. But in this case, what we're doing, we're taking our goal list and it's just going to render this kind of table. The styles aren't the greatest, I'll admit, but it's a table. That's what we're rendering, and it comes from this goal list state. The way that it works is we set the state right here when we get the data from our backend. So this set goal list is how we update our state. Instead of having to call some kind of dispatch function and then it goes through the global store and updates everything even though it doesn't need to, or it checks everything even though it doesn't need to, this keeps everything right in the same file. That way, when you need to do some debugging, it's a lot easier to find those issues of where the state is being updated or why it's not being updated. It's easy to see where your values are being used, and it just keeps things more localized. That way, you're not tracking global states for forms that only matter on one particular section. You don't need to track every single state for a page, sometimes. But that's just a quick example of useState in action. And so, getting back to this, the next one is going to be useEffect, which when this one came out, I think it gave us all a little bit of a problem before we figured out you need to have that empty array for the updates if you just want to load one time. But that was something that was always fun to figure out. In this case though, whenever, okay, so we're using another state and this is just a Boolean. It's initially false, but where this comes in at is when we decide, hey, I've completed a goal or whatever. You click on a button and it's going to update a value to say, yes, I did complete a goal today. And when you click that, it is going to make this backend request and it's going to change whether that state is true or false. Basically, it's going to make this state true because if the request goes through, it's going to have updated that specific value in the database. But we use our set whatever the value is function and we update it to the new value. And what this does is when we see that the has been updated value has been changed through whatever state thing we've done, it's gonna call the get all goals function. And that's gonna trigger every time this value is changed. So a reason you would wanna do that is maybe you need to do a quiet refresh on a page, or maybe you need to do something like set other states based on this state. It's a number of different reasons that you would look into using useEffect. But one of the big ones, originally useEffect was mostly used to get rid of, what was it, component did mount, component will mount, one of those, whatever class function that was. But basically it was used to replace when you want to do that initial load for your state. So you're calling in data from the backend to fill out a form. Maybe a user has saved some kind of custom view, or they've made some kind of, I don't know, custom report, something you drag and drop. They've made some changes and you saved them so that they'll have their custom page when they come back. Basically, you want to make sure that that particular state is loaded onto the page as soon as the page finishes rendering. That's what we use the useEffect hook for. And in that case, we would definitely want to make sure that this empty array is here to tell it we're not watching for any values to be updated We just want this to run the one time that the page loads. And the great thing about useEffect is you can have multiple of these in there. So you could have one that's just for the initial page load, and you could have another one that's for whatever value has been updated. It just gives you a way to also get rid of that dispatch method from Redux. And it makes it easier to follow the code as you go back and read through it, and you need to make bug fixes and add new features. It gives you some kind of clarity that you don't always get with Redux, because Redux can do some kind of quiet black boxy things, which sometimes if you're not quite sure how to use the tool, it can trigger some really weird state updates that take forever to track down and debug. I'm sorry, I'm a little thirsty. But that's basically what the useEffect hook is for. Is just to trigger those on-page changes that need to happen locally without having to update everything else. And now we can go back here. Again, I really wish that the useContext hook was simpler, but at the same time, it's pretty great in what it does. So sometimes you need to have a global state. Like there's certain values that just need to be shared across all of the components on an SPA. And that might mean you have to share authorization requests or user IDs or site IDs, page IDs, whatever kind of data you need to share across pages or components. That's what goes in the useContext hook. And basically what it allows you to do is to keep kind of this global state, but in a more defined way. So you can have multiple contexts inside of an app, which kind of reflects a little bit of what MobX does, but on a different level. Basically, useContext lets you put specific components in a context to use the same data. And what that means is that as you make updates to that data or you make different requests with that data, it's all shared across all of the components on that page. And what that does for you is it gives you that central, I don't want to say that central storage, but that's kind of what it is. It gives you that central storage where you know you can get those global values without needing to do prop drilling, for example. So something that you might have needed to pass 3 or 4 elements deep, you can now just pass from the parent directly to that descendant without bothering the other components that are in between the two. But sometimes you do need to have a state management tool, just because when you're working with an app that has 100+ components, it gets really hard to keep track of those local states really, really fast. So I mentioned prop drilling, 4 or 5 components deep, but imagine if you had an app like, I'm assuming Amazon would have a bunch of on-page components. So imagine if you had to pipe drill a value 10+ components deep. It would be really hard to keep track of that. And then I think useContext would help solve that problem, but sometimes you need something with just a little bit more power, something that you have more configuration control over, if that makes sense, to make sure that those values get updated at the right time. Because when you start working with those large systems, you have a lot of async processes going on, and we all know how great it is when async messes up a value update. But in those cases, you might definitely consider using a state management tool instead of just the built-in React tools, even though you might still use them in conjunction with additional tools. It will probably help you clean things up when you get to those large projects if you just pick a state management tool in the beginning and decide, hey, I guess we're gonna use Redux or MobX this time. So yeah, if you're working on a large application, be prepared because the values are coming. It's just a part of how it works. But the state management tools really do make it simpler to watch everything on a larger scale. When you're still working with those small and mid-sized applications, it's not as important to use a state management tool. But when you do get to those really large enterprise applications that need a lot, like high uptime and quick responses, and you just want to make sure that your tool is able to handle all of the different inputs and different um, component interactions as quickly as possible. And a state management tool might be the best choice for that. It wouldn't hurt to do a performance analysis if you have that kind of time, but usually it's better to just commit to the state management tool or some hybrid of the React hooks plus state management or just the React hooks. Because when you start trying to refactor into these different state managements, it just leads to a really big engineering effort because it's completely redoing your app basically. That's why it's so important to know kind of the trajectory of your app before you start managing state. Because once it gets to a certain size, it's possible to go back and make those changes. It's just a lot harder. But of course, there are the top 3 tools to consider. You probably already know about Redux, so won't talk about that one. MobX, it's not as common as Redux, but is definitely really popular. And pretty much the only difference between Redux and MobX is just that Redux has that one giant global store, and MobX you can have multiple smaller stores. So that's one of those, it kind of depends on what you personally like or what you think would fit your project better. And then if you're working with some kind of GraphQL app, Apollo has some really cool tools for state management. It used to be Apollo Link State, but they got rid of that in one of their recent updates. So I think it's just built into Apollo now, which is pretty cool. That way, if you're already using it, you don't have to import any extra packages or libraries. It just runs right out of the box. But pretty much all of these tools just run right out of the box. You just have to spend the time getting them configured right and setting them up and integrating them throughout all of your components. But now I want to go ahead and wrap up with some key takeaways because I know it's late and I don't want to hold you all night. But the first thing is please plan those components carefully, because what happens is we'll end up with maybe one really large file that has a bunch of smaller components in it. It might be worth seeing if those should be broken out into their own files. The goal is to keep your component system as clean and as organized as makes sense for your project. And basically what that means is you should be able to easily understand how the components interact with each other just by, going to the definition in VS Code or looking at the props that get passed to it. There should be some just key markers of how components interact with each other and how they should be organized just for the developers to go through. And don't use a package if you don't need it. If you don't need Redux or MobX or Apollo or any of that, don't use it. There's no obligation to use one of those tools just because we use React. The hooks have changed so much in how we make React projects that it's it's almost like a completely different framework. But if you don't need a package, don't worry about it. You probably just don't need it. And of course, just try those React hooks because they'll do the job for you about, I want to say about 75% of the time. There are some more advanced um, form libraries like React Final Form if you need to keep track of arrays of values that change depending on how you send data to the backend, or maybe you just need something that has better support for the different ways you interact with the form. I've used it a few times and it does manage those really long, complicated forms a lot better than a lot of, use state declarations and a lot of a lot of useEffect, what's the word? Implementations. So it's okay to try different stuff, but at least give the hooks the first chance. And if you do need to use a state management tool, don't feel weird about it. It's just one of those, if it works better for your application, go ahead and use it. The whole point of all of this stuff is to make our jobs easier, not harder, not more complicated. So even if everybody around you is like, oh no, we don't use state management tools, but you're getting bugs all the time because renders are happening really weird or users aren't seeing their data updated correctly, you might want to at least consider proposing using some kind of state management tool to keep all of that in mind. And then my favorite is something that we can all be a little bit guilty of. We jump the gun when the code looks good and say that, oh yeah, it works. Please check that your code actually works before you ship it to QA or support or anybody. Just do a quick click through, make sure everything's clicking like it's supposed to, buttons are triggering the right actions, inputs are filtering the right lists, and drop downs are hiding and showing like they should. But just make sure that you do a quick, user test, not just the code review, but go through and make sure the functionality works before you ship it to anyone outside of your local machine. And that's all I have for y'all tonight.